Welcome to this episode of the AEC Engineering and Technology Podcast, a podcast dedicated to helping engineering professionals find technology that fits their needs. In this episode, I'll be speaking with Bart Kemper, Principal Engineer at Kemper Engineering Services, LLC, about the vital role of a responsible in charge in AEC projects. We'll discuss key aspects like decision-making, accountability, effective delegation, and team trust, and how these factors can affect the success of your projects. With that, let's jump into today's episode. Bart, welcome to the show. Thank you so much for joining us today.
Thank you for inviting me.
Absolutely. And I know, Bart, we've connected and interacted a little bit on LinkedIn, but it's great to get individuals such as yourself on the show, kind of bring a little bit of a different perspective to the audience than our typical episode. And I think this is going to have a lot of great content for the audience. So let's jump right into it. Bart, can you tell us about your career journey and how it led you to become a renowned engineer with expertise in such a wide range of fields?
Well, I'm not too sure about renowned, but I go for useful. I try to be, it really started with when I started my career, I was commissioned and I got my degree and commissioned at the same time in 1992. I was working for a small engineering firm in Baton Rouge, but when I joined the Army as an officer, I had been enlisted. I had a mentor say, you have to understand, if you were Castles, if you're the engineer, and you're the only one in the room, you're it. You're the electrical engineer, the nuclear engineer, the petroleum engineer. It doesn't matter what it is. You're it. And they don't care whether you went to school for it or not. Your job is to get the answer. Your job is to solve the problem. They wouldn't bring it up to you if it wasn't a problem. You may have to give them the answer that that's not something we can do, but you're still speaking as an engineer. So very early on, I had the whole attitude of, if it's my problem, it's my problem. Learn it, figure it out. And a lot of what I've done is just remembering the basics. I mentioned I worked for a small firm. This small firm was working internationally as problem solvers. They're now in Houston, but they taught me the fundamentals, and they taught me how to start with the physics and work your way outwards. So a lot of what people do in normal industry is, for example, heat exchangers. If you have a problem with the heat exchanger, I'd recommend go talk to a heat exchanger company, because 9 times out of 10, it's going to be a problem they've already seen. They have a 90% solution available, and they can just roll it out, dial in the 1 or 2 variables, and call it good. They've already worked their way through that problem. But if they can't figure that out, then come back to me, because my team works on grassroots type situations where we're used to coming in from the bottom up and figuring things out. We have to set aside our bias, have to set aside what everyone knows, because if everyone knows it and they were already right, why would you come to an engineer? So that's been a lot of what we do. And because of that, well, as I said, I'm an Army engineer, but I've gotten involved with submarines, which is kind of wild. So that's just one example of how solving the problem has led to one solution to another solution to another solution. Those solutions are all interconnected. But when you start applying it to industries, it appears to change a lot because it's changing in industries. But for example, submarines is still based on pressure vessel technology, which is starting out in the petrochemical field. So for me, it was a very simple journey from doing open top tanks to pressure vessels and piping, and to doing offshore, to doing subsea, and then doing hyperbaric systems to doing submarines. Is all similar math all the way through, but it's tracking across multiple industries.
And it sounds like to me, Bart, it's really just getting back to, like you said, the physics and first principles of engineering to solve similar problems across fields, which, your example of being enlisted, right? That it sounds, pretty crazy, right? Because you go to school for typically a singular, maybe a second engineering discipline, but being in charge of all of them, right? All of the engineering disciplines that pertain to any specific project had to be pretty interesting.
Well, and it was, and that's of course why you prefer to work with engineer units where you have within that staff, you'll have the multiple engineers. But when you're the one engineer amongst the infantry, the armor, and everyone else, you're it. And that's the same thing in the civilian world. When you're within the engineering environment, yes, we'll parse it down to expertise of things that we have the individual expertise or experience in. But if you're dealing with a project startup, or you're dealing with management, you're dealing with something else like that, you might be the sole engineer or engineer that covers large swath. And you may not have all the answers available, but it's still your job to work it out and figure out who you need to talk to, what experts do you need to find, how do you vet the problem. So the problem-solving technique that we learn as engineers never stops being applied.
And I think that's a great segue into our next question, Bart. So, right, whether you're the only engineer on a staff of enlisted, or a higher ranking engineer in a civilian company, right? There's this concept of responsible in charge. Could you just describe what it means in the engineering world and why it's so critical?
Well, the responsible in charge is formally codified as a professional engineer, which is a PE in the United States, a P.Eng in Canada, in in Australia. It is a RPEQ, a registered professional engineer, Queensland, where only part of Australia has the professional engineer laws. But that's a formal codification of the concept of you have one person that is formally in charge. They may not have all the disciplines under their belt, but they will work with those people. Dr. Khan, who did the Sears Tower, he certainly did not know how to do all the electrical engineering. He didn't know how to do all the elevators. He didn't know how to do all of the plumbing, but he was the engineer in charge of building the Sears Tower. So having that one person is important, because when you are that one person, you are you're also the project manager. You're looking to see what's being done, what's not being done. And a lot of what happens is that you have your technical background, but that technical background is more towards your technical background instructs you on what questions to ask. You may not have the answers, but as a project manager, more of your job is knowing what questions to ask and then being able to weigh that answer to see if that answer is good, whether it has enough depth, whether it's on target. You build the project from there. So that responsible in charge means that you have someone to look to that carries the weight of that project. And it's important, because when you have people working committee and there's no one person in charge that has the sign-off authority, that it's not the person who puts their name on it, it's very easy to go in circles and say, I thought that other person had it, or we decided it was not important, or we decided that was okay. But things are different between we and me. That when it's your butt on the line and you guys say, no, I'm signing for this, we're going to check this. That does change the dynamic. So having the responsible in charge is critical in engineering, because this is all about life safety systems. This is the whole reason you hire. This is what I work with undergraduates when I instruct them on codes and standards. I say flat out, if people can avoid hiring an engineer, they will, because engineers cost money. If they can do it by some other means, by just designing it, just by sketching it out and calling it good, they will. The engineers are brought in when there's lives on the line or lots of money on the line. So either way, there's something big going on, and having one person in charge is really important to making sure that you're not going to have things drop out just because you go into committee mode. Now, is this a guarantee that everything will go well? No, but it does ensure there's more transparency and accountability. And when there's transparency and accountability, it does tend to tighten individuals up. Yes, if everyone had perfect ethics and perfect work ethic and it had all knowledge, we wouldn't need to have a professional engineer. We would need a responsible in charge. Everyone would know their roles. We also wouldn't need laws, regulations. We wouldn't need rules. So the responsible in charge is not to say that someone is inherently doesn't have ethics if they're not a professional engineer. Not at all. When I say responsible in charge, yes, the PE is part of that. But even without having anyone with a license, you still have the principle of there should be one person in charge that takes ownership of that and is the one that answers for it within the organization and has your name associated with it. So there's transparency of who did what, And there's accountability that if something doesn't work out, you know who to go to fix the problem. It's not about getting someone in trouble. It's about understanding what happened and how to fix a problem and get to the next step.
Absolutely. And speaking of accountability, Bart, could you elaborate on the concept of the belly button to push and how it applies to decision-making and accountability in engineering projects?
It's a military phrase, and basically you'd have someone says, I just want to know whose belly button to push, where I want to know, as let's say you're the CEO of an or a plant manager, you're some large organization person, and you want to know when it comes to this one issue, who do I go to? Who's that one belly button to push, which is obviously, I guess, an anachronism to some old advertising animation that people were used to, people my age with gray hair. But it's the idea that goes back to, I want to know who that one person is. And that goes a long way to solving that problem, because a person now knows when this problem goes up or this issue comes up, this area comes up, I know who to go to, which is ideally a very proactive thing, because if I'm in charge of, let's say, Unit AB, I want them to come to me for anything to do with Unit AB. Good, bad, and different. I want it all to come to me because I'm in charge of that unit. I work with the people there. And even if it's not exactly my area of expertise, I know who's involved with Unit AB, and it all comes to me instead of someone going around me because, I thought so-and-so could handle it because they're maintenance. No, I'm in charge of this. When it comes to this topic, I'm the belly button. And that concept goes back to who's responsible in charge. So in a big way, this is taking the responsible in charge from being the guy on the top to someone who has a sub area, and that's the responsible in charge for that one sub area. And they have the same mentality that I'm in charge of this one. So, and I want to be clear, this is very much from a civilian context, not a military context. Military gets a little bit more codified, and you have other things that go into it where in the civilian world, if your boss tells you to do something, usually it's not under the force of law, but if a superior officer tells another officer like myself to do something, then it has a force of law. And if I give an order to someone, then that has a force of law. That has its own entire system that it does work within the engineering context of the military engineering, but you just don't have that in the civilian world. Thank God. I mean, why would you want that? So, but this is very much about technical reporting and technical responsibility, and not about, trying to make this about matters of law right off the bat.
Understood. And Bart, another saying for you that I think our audience will also be interested in learning more about. Can you tell us more about signing the blame line and what impact that has on project outcomes? Well,
it's the same concept you have with doctors. Doctors have to sign off on diagnoses and treatments. When you deal with legal documents, you have the legal counsel of record signing off saying this is under my care. Well, as an engineer, the blame line is you're signing off. You owned it. I'm the one who's responsible for all that did or did not happen under this. So it's very, even within warehouse operations at lower levels, you're signing for an inventory. When you're signing an inspection, when you're going in and doing a house inspection, that's what the inspectors do. So this is not only an engineer thing. This is for accountability. Anytime there's accountability and transparency, this is how it applies. It's very codified with professional engineers, and less so in industry as a whole because of the industrial exemption. Does not mean that it's not done. It's just it's not a legal requirement the way it is, such as if you're doing pressure vessels.
Understood. And Bart, as you kind of alluded to earlier, right, we don't do pretty much anything alone, right? So as, the engineer in charge or someone who's responsible in charge, right, you're going to have a team working together with you on whatever the task is. How do you approach delegation and engineering, and what strategies have you found to be most effective for balancing control with trust?
That really comes down to the organization and the individuals. So one of the things I look at is who has what expertise. But another one that I've found to be very successful is who cares the most. If there's something that has really gotten under someone's skin, or they're just passionate about a subject, even if they're more junior, but they've demonstrated sufficient technical ability to take more of a lead, I'll give them that because I'll get that kind of response out of them. And I find that giving someone responsibility sooner than later tends out to develop them and gets things going. If you've been doing project management, you've been responsible for 10, 20, 30 years, it's just another day. But that young engineer, when they first come to say, hey, you're in charge of this right now, and we're watching, after you get that first bit lights of, panic in their eyes, then they smile and they stand up a little bit more and they go, all right, this is what I trained for. This is what I went to school for. This is what I lost sleep and had a brown memory for 5 years, and I woke up and had a degree and didn't know what, now you're actually doing it. So I'm a big believer in trying to find ways of bringing people in and give them that sense of responsibility. And here's an important part, and is you must accommodate failure. You must have ways of letting people come up short. Now, what that might mean is you plan design reviews where you go through and you look for those shortcomings and you catch the failure before it leaves the door. What I always tell my people is it doesn't matter what we do before it leaves the door. I can make mistakes, and I have people check my stuff. It doesn't matter if you catch my stuff. I mean, kudos to you. It matters to me, but it doesn't hurt my feelings. The whole reason you're here is to check me, and I'm here to check you. And what matters is what goes out at the end of the day. And so when you enable people to do work, you can always delegate the work, but you cannot delegate the responsibility. You will still own that responsibility. And you have to back that up by giving people the time and space to work their way through it. And if they come up short, to backstop them and give them a chance to learn. And and it may be a case where, so if they get to this certain point, we have to we have to give it to an experienced hand to get it across the line. But that's your plan. And there's nothing wrong with that. That young engineer still has a chance to learn. But that's one of the biggest things is you have to have a plan for when things don't go well, because engineering projects, even on the best conditions, you still have outside considerations that you have no control over.
Which is another great segue into our next question, right? Because like you said, it's part of any young engineer's, process of learning from, being in school to being an individual contributor, managing others, and eventually becoming, right, responsible and in charge. How do you cultivate an environment where team members trust each other enough to embrace failure? Why do you believe this approach is beneficial?
It has to start with the leadership, period. I mean, it has to, you teach by example, you lead by example, and you have to demonstrate that. You have to be able to talk your way through it. If you can give examples of your own shortcomings, like, hey, here's an example where I missed this before and we had to redo it, that's fine. If you're going to expect someone to stay late, and here's a very simple example. If you expect someone to stay late to fix it, maybe you should stay late with them and at least be in the office with them. So you're there. If they're at 10 o'clock at night and says, hey, I got it done, boss, you're right there, not at home. You're right there with them. So you're embracing the suck with them. You're embracing the same. You didn't go home when they were just checking in with you, especially when they're young engineers. You're right there with them. It's okay, let's go through this together and work this out together and go through the checks. If you're willing to stay late with them, if you're willing to do the same thing with them, that goes a long way to teaching that. And of course, if they see you staying late and you're saying go home, because what you don't want to do is have a situation where it becomes a badge of honor to stay late all the time. That's not the point. The point is you do it when you need to. Now, you may have deadlines that happen because, especially in my case, in our case with our firm, we do a lot of rapid response. We'll get a phone call literally on a Friday and say, we plan to turn this unit back on Monday. We need an answer to see whether it's safe to turn the unit on. It's like, can you do it yes or no? And that, of course, means it's, a whole weekend worth of working right off the bat. But that's the nature of the job. That's an emergency response type job. But we don't stay late just because we're trying to show off to anyone. And you don't want to teach the young engineers that. You actually want to try to give them some measure of balance. And ideally, you do things such as, we've done things where we had company ditch day. We already had the work scheduled around it. And we took the whole company and everyone's significant others and everyone's kids to a water park. I spent the day just doing that. We've gone to movies when there was a major movie coming out and said, who wants to see the movie? Let's all go. It doesn't replace the times you have to work late, but it does show that you pace yourself. It does lead by example to say, when we have downtime, we do this, but when we all have to work, we all work. And that gives you that sense of it's not a complete grind. Now, when you get all the way up into management and you're handling a lot more things, but that's the price of being in management, where you may have to be juggling multiple jobs at once and you punch longer hours. What I've seen less experienced managers do is think that was good to do instead of an exception, and then basically try to brag on it and somehow give the idea this is what I expect of others. And then you get that whole culture that everyone's waiting for the boss to leave so they can leave. And that's definitely what you do not want to build.
And like you mentioned, Bart, right? It really goes back to that first principle that you noted, right? It all starts with leadership, how they act, how they behave, and ultimately the example that they set for everybody else that's working with them.
Absolutely.
So Bart, we've talked, we've talked about a couple of, let's say principles in engineering, right? Whether it be in the military, civilian life, codified ordinance, et cetera. But how are these principles that you advocate for in engineering applicable and beneficial across different professions and industries?
Well, as I said, there's already parallels. When you have a person that is responsible for a significant task, be it medical, your CPAs, they have to sign for things. Lawyers, I think anytime you have where you have a task that is the consequence of failure is significant, that's kind of significant, meaning loss of life or major loss of work, or in NASA terms, loss of mission. That's it. The same principles apply. And just nodding back over to the military side, I was in the Army Reserve. I was active duty enlisted, but then I became an Army officer in the reserves, and as a reservist has served the active duty a fair bit. And I've worked with other militaries. I've worked with the Navy, and I've been underway with the Navy. I've worked with the Air Force. And this does apply across the board in that it doesn't matter if you're doing administrative work or you're doing legal work or you're doing supply work, you still have that lead by example and that need for accountability and responsibility. And the military is codified at all levels in every task. In the civilian world, though, it's kind of hard to do that at times because in the military, even the most mundane task has a mission behind it where it is connected to something that's a bigger life and death picture, whereas someone working in a lower level work in, let's say, a large warehouse doing mail order stuff may not feel connected to that. And that would be a challenge for the leadership of what is the appropriate level of connectivity to that. So if the person can't see it, you can't really demonstrate it to it, you can't really live it, maybe it's not that high of a priority. Maybe you can't really try to sell this as if you're getting ready for D-Day. So that's, I think, something I've seen on the civilian side of it is when someone very clearly is worried about their job as a manager. But how is that my problem as a worker? It's like, yes, you're all stressed out, but why is this my problem? I'm doing my job. I'm doing what you told me to. You're my boss. Why are you doing this? And that's where you have to find that balance point in the communications and dial into what works, because not everything can be treated as if you're working on a bridge project and if you make a mistake on these cables, the whole thing falls down. That's usually not the case.
Bart, and these have been some really great examples to drive home kind of the principles that we've talked about today. And I guess the last question for the interview today is, what advice would you offer to engineers, both aspiring and established, to navigate and succeed in today's complex engineering environment?
Remember the basics. It's amazing how often the engineering solution can come from what was done in high school physics, and how often, as a part of my practice is as a forensic engineer. So, and I'm the editor-in-chief of a peer-reviewed journal for forensic engineering for the National Academy of Forensic Engineers, NAFE. And a number of the engineering faults I've seen is because they did not start with first principles. They quote unquote knew what the answer was, jumped to that answer, and then because they had bias confirmation going on, they justified their answer. But when you take a step back and really look at the problem and solve the problem, it comes out a bit different. And so often that the college, your first physics course, your senior high school physics course, the kinematics equations, the heat transfer equations, those one-line equations that you can kind of eyeball just by looking at it, and maybe scratch it on the back on a board somewhere with a marker. That'll give you that sense of what's up and down, what's left and right, what's big and small, and give you that sense of proportionality that'll get you out of a lot of problems. Of course, if you want to give work to me as a forensic engineer, then don't do that, and I'll catch you on the backside.
Excellent answer. And Bart, I just wanted to give a shout out to one of your recent F.NSPE webinars titled Professional Engineering Ethics, Risk, and Liability with Technology. That's actually how I got my introduction to Bart's work. And seeing as this is a technology-focused podcast, I think it'd be valuable for the audience to take a look and review, because with the pace of everything that's going on, right? Large language models, other subfields of AI, right? Cybersecurity was a focus in the webinar that you put on. It can be easy to get lost or impressed by the flash of some of these technologies, but I'm really glad we had you on today, Bart, because your message resounds, right? Even as the technology becomes more advanced and things appear to be more complex, right? There's always first principles to go back to as engineers. And Frank, when I tell everyone, right, we are still in charge and responsible regardless of what tools we use. So again, thank you so much for joining us today.
Thank you.
And Bart, what is the best way for the listeners to connect with you if they have any more questions about anything we covered today?
I'm the only Bart Kemper in the United States. So I am annoyingly easy to find. They can reach out to me at my business email of bkemper@kempereng, KEMPERENG.com. If they do a Google search for Bart Kemper, they'll probably find me one way or the other.
Excellent. And we'll make sure to include Bart's email, Bart's LinkedIn page, and then a link to the webinar I mentioned in the show notes. So again, Bart, thank you so much for your time.
Thank you.
Please remember, you can find the show notes for this episode at aectechpodcast.com. There, you will find a summary of key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, I wish you the best in all of your engineering and technology endeavors. Thank you.